problems.
That is true, actually.
Okay.
Yeah, so it says right here, what percentage of 10,000 women, so that's your whole, right? And a positive mammogram.
So you look
I love how
look-
we're talking about
look at positive mammograms. We got a total of 6432. And if I do the part to whole, that would be 6432 over 10,000. Put that in your handy dandy calculators. Actually, you're just going to move the decimal place over 4 zeros because you're doing units of 10. So this equals, you ready? 64.3%.
I need none. Like, I already have 4 minutes. I used to be a tryhard, so now I'm like.
All right. What percent of 10,000 women?
So is 10,000 your part or your whole?
Your whole.
Okay, there you go.
See, now you're paying attention and you're getting things. Okay, so what percent of 10,000 women had a cancer diagnosis? So definitely had a cancer, which is 378. Had cancer. So all you have to do is use your handy dandy calculator again, or there's 1, 2, 3, 4 zeros, so you're just going to move the decimal place over. Never mind, I'll use the calculator.
4 times?
3.7 or 3.8%.
Right. So I got to take 378 divided by 10,000. 0.0378. Move your decimal place over 2 places. And I get 3.8%.
Let's go. I'm on fire.
See. Let's see, what percent of women, so what's my whole? That's right, 10,000.
Tumayo.
302.
What percent of women had cancer? So had cancer.
302.
I'm looking at this row, right? Had cancer and had a positive. So I'm going to use 302. Right? Cancer, positive, 302. And I better use calculator again because we trust the calculator more than the teachers these days. 302 divided by 10,000. 0.0302. Okay, look at that. 4 places it moved it over. Okay, 2 digits. My percent is 3%. No, wait. Whoa, I did a mistake here. Let's see, what percent of women who had cancer? Okay. So that's my total, though. 378. I screwed this up. See?
Oh, so
Didn't
it's
have.
not supposed to be 10,000.
Yeah, right.
Because that's just, the 10,000 says women, but we want to look at who had cancer right there. So
Right
that's
out.
your, what, 378?
See, that's what happens when I haven't had coffee.
378 on the bottom. All right, so basing it off of what I see.
Is that really just like tape?
Yeah. I love whiteout. I go
Um,
No, just those.
Smell it, bro.
Like
What are you
those
talking
rolling
about?
ones. I hate those. I hate the wet ones. Those are
You
disgusting.
like
I
tape
don't
today?
drink if you never get them. I know. I like those.
No.
okay, let's try this again. Women who had cancer is my total, and that's 378. And this one I better use a calculator. Uh, 0.7989. Round that up to 9. So 79 0.9%. Yep, much better. By the way, what does that tell you about the mammogram test? You're looking at 80% positivity rate of women who had cancer tested positive. What does that tell you about the mammogram test? Because this is what you guys need to do eventually is interpret this data, right? Anybody can compute data, it's interpreting it that's the hard part. 80% of women who had cancer tested positive on a mammogram. Can you say what can you say about the mammogram test?
That it's not 100% accurate.
Yeah, it's not 100% accurate.
But it's close enough.
It's 80%, which is still
Good percentage.
it's still pretty good, but not.
We're still.
Yeah. Two out of 10 women don't get diagnosed, right? That's pretty high in my opinion. All right, next one. What is going on? There we go. That's a little better. All right, D. What percent of women who had a positive mammogram? So there's my total again, right? What percent of women who had a positive mammogram? So are we looking at? So it's going to be the 64-32 because all of these women had a positive mammogram, right? So I'm looking at 64-32 positive mammogram, 64-32. Had cancer. So how many had cancer? 302, right? Yeah. That remember, we're still under the condition that they had a positive mammogram. If they wanted total, all the people that tested had cancer, then we would use the 378. All right, handy dandy calculator. C3. Why does my calculator turn off? That's irritating me. But then again, it's not taking much because I haven't had my coffee this morning. Point 0.4695. Let's round this up. Let's see, 4.7. Okay. So what percent of women who had a positive mammogram had cancer? Explain why the answers to parts C and D are not the same. What do these two percents actually say about the mammograms? Well, I think we kind of explained that already, right? It's really not. It's really not 100% accurate. In fact, there's a lot of false negatives. Okay. Next page. Oh, we're getting into relative frequencies.
No way someone has decided about that.
Oh boy. Okay, what is relative? Oh, why is a relative frequency also considered a probability? Um, Maybe we should start at the beginning. In this section, we will focus on calculating what percent of the time an event happens, then interpreting those percents as probabilities. You should try to focus on the following questions. Do you remember how to find the percent? Of course we do. We just did it. Why is a relative frequency also considered a probability? Well, we don't even know what relative frequency is, right? So let's define that. Relative frequency is the ratio formed when the frequency is divided by the total number. Wow, what's a frequency? I don't know. Well, let's define that. Don't you hate it when they use words that you don't know to define something? Frequency is the number of times an event occurs. Okay, for example, if 15 women in a group of 75 were diagnosed with cancer, then the relative frequency of getting cancer in that group is 15 out of 75, 15 divided by 75, which is 0.2 or 20%. A relative frequency can be expressed as a fraction, decimal, or percent. Oh boy. So let's do some examples, right? All right. Let's see. Each year, general survey asks respondents if they are working full time. We have a couple of conditions here, right? A survey. We have working full time, working part time, or going to school. Well, some of you go to school sometimes. Or, oh, we got another one. Keeping house, and so on. In 1972, geez, that's my time, 1,650 people, 15 people responded. Wow. So we have 60. What do you think the 1615 is going to be representing? 1615 is probably somewhere in this thing. It's going to be our whole, right? 750 of them were working. They give us all the answers. That's not fun.
Very fun.
They got the solution right here. I didn't even realize they got the solution right there. 715 were working full time. So you know how to figure out each full time, part time. So you're just going to take the part, whatever it is. Like full time would be 750 over the 1615, and you get 46%. Part time, let's see, 121. Part time is going to be 121 over 1615, and you get 7%. So that's how they get those numbers. The relative frequency, let's see how they got that. The relative frequency of full-time workers was, let's see, find the relative frequency of full-time workers in the relatively frequency of part-time workers. Okay, so the relative frequency of full-time, um, they got 1230. How'd they get 1230? I don't see relative frequency. It doesn't make sense. Okay, the number of times the events. Oh, there it is. 2538 is our total. Would help if I read the whole problem, right? So that's going to be my whole. And 1230, we're working full time. So that's how they get to 1230. So let's do it ourselves. Wouldn't that be fun? A national survey asked how many people were living in the respondent's household. The following table shows the results. Find the relative frequency of households with more than 8 people and interpret it. Okay, so more than 8 people, does that include 8? No, it's got to be more than 8, right? So we're looking at 9, 10, and 11, right? So that's going to be my part. What's my whole? Anybody know? How do I get the whole? Well, I'm going to add each one of these, right? 695 plus 997. So I'm going to add all these to get my whole. Does that make sense? I need the entire amount of people, number of respondents. So I need to add all these together. Get it? All right. You guess so? Do I need to hit you over the head to get it? 695. We need the total number of respondents. That's what I'm getting. Okay, so I'm just going to add the number of respondents to each one of these. That'll give me the total. 695 plus 997 plus 385 plus 261 plus 132 plus 47 plus 15 plus 1 plus 3 plus 1 plus 1. So my total, 2538. Okay, so we need the relative frequency of all of these that are greater than 8. Okay. All right, so greater than 8, I'm looking at 9. How many do I have for 9? 3. So 3 out of 2538. So that's my part to whole for 9. What's my part to whole for 10? Good. And my part to whole for 11? What am I going to do with these 3 fractions? Throw them in the trash. I'm going to add them together. Okay. So that gives me 5 out of 2538. So there's my fraction. Let's do a decimal. Let's see, 5 divided by 2538. There's my decimal. 0.00. I'm going to just put a 2 there. Hit math enter enter. Or we could just say 0.2%. I got my fraction. I need my percent, right? Move this over 2 places. 0.2%. Wow, that was easy. Relative frequency with more than 8 people. Oh, we got to interpret it. Let's see. Find the relative households with more than 8 people and interpreted it. Um, I would say there's not a whole lot of people that have families of 9 or larger. That's the way I would interpret it. Do we have time to do another one? Relative frequencies can be quite small, as you saw. It's 0.2%, and it's important to able to correctly interpret the decimals that result in a useful way. Remembering place value, of course. Should we go on to experimental?
Could you experiment more?
I think.
We probably got time. Okay, experimental probability. Let's see. It's the likelihood or chance of something happening. So there's a definition. Probability tells us the likelihood or chance of something happening. Relative frequencies tell us that what percent of the time something did happen can also be considered experimental probabilities. Example, recent surveys showed that 40% of Americans approve the job of the president is doing. Nope, that's just not true right now. By the way, I stopped for a gallon of milk last night.
What?
Have you guys bought a gallon of milk recently?
Me and my manager were just talking about this last night because she said everything is like skyrocketing in prices.
Yes.
Milk is everything.
$4.
And even meat, like you can't find.
If we go to Aldi, they won't let us buy more than 6 gallons, and it's a restaurant, and we're like, fuck you.
Oh, I'm recording.
You gotta go to GF. Was it
GFS?
Yeah,
Don't go
GFS.
there. Don't go there.
No, but for a restaurant.
No, don't go there.
What up?